All right, so several of you, sorry, I didn't mean to have you looking at the ceiling. Several of you, I don't know why it's flashing, were asking about or how to know when to choose appropriate graphs. So the biggest thing I can say, and honestly, the two graphs you're going to do the most are bar and line. Bar graphs are when you're comparing groups. So if you're comparing, how many freshmen, sophomore, juniors, and seniors are there at White Knoll, or if you're comparing how many flowers bloomed at 1 o'clock versus how many flowers bloomed at 2 o'clock, or if you're comparing the heights of girls versus boys and you're graphing that mean height. With a line graph, it's going to be when you're looking at continuous data. For example, over time, let's say we're running an experiment and we want to know. We want to take data points at 0 seconds, 30 seconds, 1 minute, but it's the same sample that we're taking the data from. And so it's continuous data over, say, a 10-minute period. That's going to be a line graph because that line is showing that continuation of that data collection. Pie chart, we don't do these in AP Bio. I know they're cute. They're kind of fun. Not in serious science. We don't do pie charts. So no pie charts. Scatter plot is where it's kind of like a line graph, but you don't connect the dots. You just put all the points on there. Sometimes you do a line of best fit, but you're looking for some kind of relationship between the variables. So you're looking to see if there's a correlation there. Box and whisker plots, I wish I could tell you that we never do these. I have literally never done one of these. The best explanation I can give you is that we would do these when the median doesn't make sense. The mean doesn't make sense. For example, if we look at geography majors from University of North Carolina and their average salaries, if you look at the mean, it's something like, I don't know, in the hundreds of thousands of dollars. Well, geography majors don't make a lot of money, generally speaking. But Michael Jordan was a geography major, so he is skewing that mean. So in that case, it would be better to look at the median salary of geography majors from University of North Carolina, not the average, not the mean. And so that would be an example of when a box and whisker plot, when you have some crazy outlier that really skews the mean. Honestly, other than practicing them just in case they're on the AP exam, we're never going to use these. And then the last one is histograms. And histograms are when you're grouping data into bins. And you just want to make sure when you're doing this that your bins don't overlap. So if you go from, like we did this with height. If you're looking at 150 to 159, 160 to 169, don't do 150 to 160 and then 160 to 169, because then if you have somebody at that 160 point, you don't know which group to put them in. And so that's it. And a histogram is just a bar graph. You're just looking at clumps of data instead of individual pieces. All right. So another thing that was asked was about doing the scaling on the axes. And the thing with this is, and y'all know this and y'all do this, so you may just not have understood what I was asking. Let me pull this up here. Is the appropriate way to scale an axis is even scaling. So you would do by 5s or 2s or 1s or whatever. But an inappropriate way would be, let's say I'm looking at this data and I'm just going to say we're going to put 5, 8, 12, 18, 22. So I've got them evenly spaced, but this is a difference of 3. This is a difference of 4. This is a difference of 6. This is a difference of 4. That is not evenly spaced. So that would be a big old fat no. Instead, what you would want to do is 5, 10, 15, 20, 25, 30, and so on. So that's what I mean by even spacing on the axes. So I hope that helps. If you have any other questions, let me know.